Here we're going to find the oblique asymptote of this rational equation. I know it's an oblique asymptote because the highest degree of my numerator, which is a 3, is bigger than the highest degree of my denominator. To find the oblique asymptote, we're going to do long division. So I want to know how many times does this go into this. So since there are 3 terms that I'm dividing into it, I'm just going to look at the first 3 terms first and ignore that minus 1. I am going to focus in on the first term here, the x squared, and think, what can I multiply x squared by to get x to the third? And that's an x. So let's try x first. And we're going to multiply x by each of these terms. So just like with long division, you always multiply and then you subtract to see what's left. So I'm going to draw a line here and I'm going to subtract all of this in orange from the x to the third minus 3x squared plus 3x. I am going to, just for simplicity's sake, I'm going to say I'm going to subtract this. I'm going to subtract this, which is subtracting a negative. It's the same as adding. And I'm going to subtract this. So now that I've added those subtraction signs to each of those terms, now I can just add straight down. So x to the third minus x to the third cancels, and then negative 3x squared plus 5x squared is 2x squared, and 3x minus 6x is minus 3x. Now I'm going to, and then I need to bring down the next. Now I want to think, how many times does x squared minus 5x plus 6 go into this? So again, look at the first term. I have an x squared and a 2x squared. What do I multiply x squared by to get 2x squared? 2. So let's try a plus 2. And now let's multiply each of these by 2. And really at this point we're done because you do not care what the remainder is, but just to finish it up, I'm just going to subtract this whole thing. So I'm going to subtract the 2x, I'm going to subtract the minus 10x, and I'm going to subtract the 12. When I do that, that cancels out. I have a 7x minus 11. Minus 13. So again, you don't care about the remainder. All we care about is what the answer is here. This is our oblique asymptote. Our oblique asymptote would be at y equals x plus 2.